So today we are going to try out NumPy and Pandas. So we already been introduced. They were already been introduced last session, but this session is only about NumPy and Pandas. Okay, for this session, I'm going to use Colab. So you can also get experience how to use Colab. But if you wish to use your local machine, by all means, just follow the instruction, same as we did last session. If you like to use Colab, as I'm going to do, then just follow me up. So first, go to colab.research.google.com. Prepare your hand font because you need to sign in using your Gmail. Okay, after you open Colab, click on the blue button, sign in. And then use your personal Gmail or Utah should work as well, so it's up to you. I'm gonna use my personal email. Then you need step 2, verification. Then you need to verify, yes, it's me. Then I'm ready here inside Colab environment after I have signed in. Okay, now next step. What you need to do, go to the GitHub and copy the URL. Go to the GitHub, copy the URL. Then go back to Colab. Go back to Colab, then click on File, then open Notebook. Then this window will pop up. Go to GitHub section. Because I already signed in to my account. But you paste here the URL. So enter a GitHub URL or search by organization or user. So just put the GitHub URL, then click on the little search button. Then you will see that the repository has been selected, DM-practicals. Now, this was for last week, practical 1. For this week, we're going to start with NumPy. So you click on practical 2/prac_NumPy. And now you should be ready. You should get like this. Okay. And why did I sign in? Because if you need to execute Python code, you have to sign in. If you just want to browse the notebook, then no need. If you just need to browse the notebook, then no need to sign in. And if you haven't connected, then there should be a button here on your side, but here automatically has already been connected. And this is my machine specification. So I have the system RAM is about 13 GB. And the disk space is about 226 GB. And I have 2 active sessions. That's weird. That is from my previous session. I should have stopped it already. Okay. All okay. So you can, okay, I have terminated my session, my current session. No problem. Then I click reconnect. I'm not gonna reconnect now because I'm not gonna execute. When I need, then I'm gonna connect. Okay, so now for this session is about NumPy. You remember what we use NumPy for? NumPy. To say hi. So NumPy stands for numeric Python, and we use it to define matrices. Right? Because Python by default doesn't have definition for arrays and matrices. So if you want to use NumPy, if you want to define arrays, then you need to use NumPy. Okay, now NumPy is installed on this machine. If you install Anaconda or use Colab, NumPy is external library, and it's going to be installed and prepared for you by default. But if you are using another machine where only Python is available and Anaconda is not installed, so NumPy may not be there. So in order to install NumPy, so for installation NumPy, then you need to write pip install NumPy. So this is we're giving in order to install NumPy package into this machine. But anyway, as I said, Anaconda and Colab have installed NumPy by default, so you don't need to install NumPy in here. Okay. But in order to install, you cannot write pip install NumPy here in Jupyter Notebook straight away, because this is not Python command. This is not Python command. In order to execute, this is shell command or command prompt. Okay, so you need command prompt to run this command. Or there's another way. Let's say I need to run here. Then for Python environment, sorry, for Windows environment, you need to put the exclamation mark first, this symbol, then followed by pip install NumPy. So this will tell Jupyter Notebook that this is not Python command. This is shell command. Okay? So I'm not going to install anyway. If you intend, if you try, actually it's not required for Colab. If you are working on a machine and you wish to install, then you can go to the prompt and then type here install NumPy. Of course, on this machine is already installed, so you see that requirement already satisfied because it's already there. Okay. Okay, then back here. Now to use, we need to import the package. In order to import the package, we need to use import NumPy as MP. We already explained this last week. And then we can create different arrays like one-dimensional array in this case, or two-dimensional array. So in order to have two-dimensional array, you need to specify this way. So this is going to be treated as one row. So in this case, I use the square brackets. But then for each row should be engulfed in another square brackets. So in this case, this here is first row. This is my first row, and this one is my second row. Okay, so you need always to enclose by square brackets. This is one row, then comma, and keep adding on. Okay. So this will create two-dimensional array. Now, in order to access the elements inside the array, we need to use indices. So we can use an index like this, or if we have two-dimensional, then we need to provide the row index, comma, the column index. So in this case, I'm looking for an element which is located at row index 1 and column index 2. Okay. Another useful or very useful attributes for NumPy is shape, ndim, and dtype. Shape is going to provide you the shape of your matrix. In other words, it's going to provide me how many rows available, how many columns available in this matrix. So for array 2D, this one, so it's going to show me the shape is 2 by 3. Meaning I got 2 rows versus 3 columns. Good. Then the number of dimension, if you like to query about the number of dimension for this matrix, you can type ndim. Okay, so ndim is going to return how many dimensions you have. So for this array, we have 2 dimensions. And finally, you can query about the data type. What type of data are stored inside this matrix? So this one tells us, since my all elements are integer, so it shows me that the data type is integer 32. What does it mean by 32? Is there 33, 34, 35? What does it mean by 32? This is same like other languages, not only in Python. 32 means the number of bits that are used to store a single integer inside this NumPy array. Okay, so each number here is taking 32 bits from the memory. That means how many? How many bytes? 32 divided by 8? Sorry? 4, right? You cannot have 3. Usually you have 2, 1, 2, 4, 8, 16, but it's good. At least someone tries. Yeah, so 32 by 8, you have 4 bytes. has been used for each and every integer inside this array. We have also 64 for long. You know long, data type, so use 64. We have 16 for short. If you are using C#, then they use short. If you have 1 byte, you use byte. So byte, short, integer, long. Okay, so all determined by the number of bits that are used. Anyway, now we move on. You can also create NumPy in different ways. We have more functions to create NumPy array. So you're already aware of array function. Array function, you can create 1 dimension, 2 dimensions array, and so on. There's also zeros. Zero is going to create an array where all the elements of the array are 0. In order to use, we need to specify the shape of the array. So here we're saying we need an array, NumPy array, of 3 rows versus 4 columns, and all the elements, all the items inside this array are set to 0. Ones, same way, we provide the shape, and this is going to create NumPy array where all the items of the NumPy array is 1, is the value of 1. So you can see the output here. Then we have range, array range. Do you remember the function range we talked about last week? Anyone can call his memory? If you cannot find, maybe shake your head a bit. Try to find the piece of information. Maybe on drive C, drive D, drive E, where, who knows? If you cannot find, then locate, check the dustbin. Maybe already thrown the dustbin. So range gives us what? Yeah, it gives us range. Very good. So range gives us a sequence of values. So here in this case, we specify starting of value 1, ending with value 9. Very good. Wow, excellent. So always remember, this is exclusive, while this one is inclusive. Okay? Yeah, so this is NumPy range, so similar to the range that is provided by Python. In short, it is similar. It's not same, but similar. So here we get values, sequence of values starting from 1 to 9. Now let's work on these arrays that we have created. So now I'm going to focus on array 2, and let's see what we can do when we use indexing and slicing. So if we need to approach specific value, you already know, we need to specify the row index, comma, the column index. How about this one? If you only specify the row index in 2-dimensional array, what does it mean? This one will retrieve the entire row. This one will retrieve the entire row. Or an alternative way, you can also write array 2, then you can put 0, comma, then column. Column means all columns. We didn't specify anything. Okay? Or even just you can have comma. That's fine. Now, in order to approach or select or get the last column, how to get the last column? So this is my array, right? This is my array. How to get the last column? So the last column is going to be which one? This one, right? This is my last column. How to get the last column? So there are several ways. If we use the same way like earlier for the previous examples, then we can type array 2, then which column, oh sorry, which row? Which row? Okay, good, but which row? Second row? We need all rows. Wow, good. We need actually all rows. Why? Because if you check here, this is the rows. So the data coming from row index 0 and row index 1, correct? So we need all. So we can put just column, means all rows. Then comma. Which column? Just now what you said, 2, right? So index 2. So this is index column index 0, column index 1, column index 2. Then you can specify index 2. This will give me the last column. So this is way number 1. Another way, what you can do, Another way. Now here, another way, if I need just to tell Python the last column, regardless of the index number. Maybe another array, the index number for last column is going to be 3. Another array, the index column for last column is going to be index 4. But if I don't need to inspect how many columns I have and then what is the index for last column to do like what I have done here, then an easy way, I can just type like this, array2, then all rows, comma, -1. -1 means last column. So here we come for zero-based indices, the positive indices. You can think of these. These are like the positive indices. So we start from 0, 1, 2 like any other programming language, right? But if you wish to use the negative index start from right to left. So negative index start from right to left. This is going to be -1 index of -1. This is index of -2. This is index of -3. So you can either use the positive index that we all know already, or you can use the negative index. This is why here I put -1. So -1 refers to last column at index 2. Okay. Okay, so this is why here you just put colon, then comma, -1. This will give you the last column. Now, if you wish to do slicing, okay, let's say I'm interested, in this case also, I have sub-array or sub-matrix. So here my matrix has 2 rows versus 3 columns. Let's say I'm interested to retrieve this part only. Okay, I need sub-array. So in this case, I need to use what technique? Slicing. So you need to apply slicing. Then I come and do what? Array2. Then I need to inspect where the values come from, which row. Is it all rows or any specific rows? All rows, right? So here, all rows, they're coming from row index 0 and row index 1, simply all rows. Then just I put column, comma. Now, how to specify index 1 and index 2. So here, this is, I'm using the positive indices. So this is 0, 1, 2. So how can I specify? I need to use similar way like the column. Then I come here and say 1, column. That means starting from the column index 1 up to, okay, this is confusing, should be 2, right? I should write here 2. But Python, when you use slicing, this is the starting index, right? This is the starting index. The starting index, same like the concept and range function. Starting value there is inclusive. Same way here, when we have slicing, the starting index is inclusive. The ending index is exclusive. So if you put 2, for example, then only this row you will retrieve only column index 1, because this one is exclusive, while this one is inclusive. Okay? So in this case, what I need to do here? Yeah, so I need to put +1. Where's the eraser here? Okay. So I have to use 3. This is also way number 1. Or another way, I just can type array2, then column, same. Then just I put 1 column. I don't specify the ending index. No need. And this is easier, right? Till the end. So that's it. So you have now 2 ways, either this way, where you need to specify the starting index and the ending index, or just to specify the starting index in this case, because we're taking the rest of the rows, the columns, the rest of the columns. So starting of column index 1 until the end. So this means until the end. Okay, so this one will slicing for second column onward, because I did specify the ending index. Another useful function is reshape. Anyone knows what reshape does? Reshape. So as the name indicates, it's going to change the shape of my matrix. So my original matrix has 2 rows versus 3 columns. Right or right? Right. Now I wish to change to 3 rows versus 2 columns. So actually how reshape works, very easy. So currently I have 3 by 2, 2 by 3. And now I'm applying reshape to become 3 by 2. 3 rows versus 2 columns. Then my array is going to look like this. So I'm going to have 3 rows. So I'm going to type the indices for my rows. So this is row index 0, this is 1, this is 2. And then I'm going to have 2 columns here. So 0 and 1. All right. Now it's going to take those values and put them in sequence. So 1, 2, 3 is going to be 1, 2, 3, followed by 4, 5, 6, 4, 5, 6. Okay? This is how reshape works. Just simply you are looking to change the current shape for your matrix. Okay, Bagus? Okay, good. Double Bagus. Another useful function is flatten. So flatten just simply is going to change my current matrix to become a vector. Flatten. Because sometimes you may need to flatten, let's say you are working on image processing. So some algorithm or some structure for neural network, for example, requires you to have the image in one-dimensional array. So you need to use flatten. If you want to transpose, then you can also transpose your array by calling the array name followed by .t. So T stands for transpose. Okay, always you can approach check what section. So now we are still in creating. Now we move to mathematical operations in NumPy. So NumPy also offers you to do all arithmetic operations, the basics one, you know, addition, subtraction, multiplication, division, and dot. What is dot? New operation, right? New arithmetic operation. So what is dot? Dot comma or .org or .edu.my. Okay. So this multiply, simply this is called element-wise multiplication or element-to-element multiplication. Element-wise multiplication. I have to enhance my font, and so I need to write slowly. Okay, so this is about element-wise, meaning if I have, let's say, 2 arrays like this one, 1, 2, then multiply by 3, 4, then the output is going to be like what? So element-wise mean element to element. So it's going to take the first element of the first array multiplied by the first element of the second array. So these two are going to be multiplied 1 by 3, then you should get 3 here. Then you take the second element from the first array by the second element of the second array. Then 2 by 4, 3. So 2 by 4 is 8. So you get 3, 8. So this is what does it mean by element-wise, okay? While this one is just simply the array or matrix multiplication. This is matrix multiplication. So what is matrix multiplication? If you remember from high school, because for me, I remember more from high school, probably, or first year of degree. Also, we talked about matrix multiplication. So what is the condition to apply multiplication into two matrices? Do you remember there was precondition where it says the number of columns? Anyone can autocomplete? Yeah? Exactly, very good. So the number of columns of the first matrix must be equal to the number of rows of the second matrix, right? So if I have matrix like this, let's say 1, 2, 3, 4. So the number of rows here is just simply this one is 2 by 2. Then if I need to apply dot multiplication, then the number of rows must be same to the number of columns here. So the number of rows of the second matrix must be equal to the number of columns of the first matrix. That means it has to be 2 here, has to be. So let's say here I put also 1, 2. Then I'm interested to keep it as 1 column, no problem. Then how we do multiplication? This has become mathematical session. Then we take the first row here, right? We multiply by the column here. And then we get the first element. So 1 by 1, 1 plus 2 by 2, 4. So the result is going to be 5. And so on and so forth. The output should be the number of rows here, 2, and the number of columns here. Then 3 by 1, 3 plus 4 by 2, 8. 8 plus 3, 11. Okay, good. Now you know the difference between element-wise multiplication and matrix multiplication. Well done. Now you can pass your math class. Okay. Also, NumPy offers other functionalities like exponential, also sqrt square root. If you like to calculate the mean value for your matrix, you call mean. Max, finding the maximum value inside the matrix, finding the minimum value inside your matrix. And here are the outputs. Okay, now we move on into different topics, but we're still inside NumPy. It's about generating random numbers and arrays with NumPy. I'm sure that you have used random somewhere, like in C++ before, where we can request from the machine or the language to provide us random values. In order to work with random values, you can use NumPy again. NumPy has a module called random. So I can approach this module by specifying the alias name for the package, followed by the module name random. Then you have a set of functions like rand. Rand is going to generate random values between 0 and 1, single value between 0 and 1. So if you generate, for example, we got here 0.5. If you rerun, you may get some other value because it's randomly generated. If you wish to generate more than just one value, you can specify saying I'm interested to generate 3 values. Then this one is going to create one-dimensional array with the 3 random values. If you like to have 2-dimensional array, you can specify also the shape. number of rows followed by the number of columns. Okay. If you wish to generate integer random values, then you can call randint. Randint, this one is going to generate random value where you can specify the lower bound and the upper bound for your integer value. So here, this is the lower bound, while this one is the upper bound value. And then size simply is how many values we wish to generate. How many values we wish to generate. So this one is going to create random values. These values are in between 1 to 10, and 5 values are going to be generated. Now we move on. Also, if you wish to generate random values, but following normal distribution. Have you heard of normal distribution? Or Gaussian distribution? Okay, anyone can help to explain what is Gaussian distribution? Gaussian distribution, what is Gaussian distribution? Gaussian? Okay. Gaussian distribution usually follow what shape? If I like to draw in 2D, usually random distribution follow what's called the bell shape. So the bell shape look like this. It's gonna look nice. Okay, good. 9 out of 10. Not bad. Okay, oops, this is not correct. That's okay. Okay, now what is the purpose of random distribution? Let's say we are talking about grades, right? We are when all students like to talk about grades. Anyone doesn't like to talk about grades? Maybe salary. If you become an employee later after you graduate, then you can remove this, put salary. Now you are a student, just focus on grades. Now let's say this is 0. The maximum mark you can get in any course, 1000, right? 100. So here is going to be maximum. On the x-axis, of course, should be here, 100, better. Okay, assuming, let's say, be optimistic that all students pass, so I'm going to put this 50, though it doesn't make sense, but it's okay. And then let's say here we start with 60, and here is going to be 75 and above. Now, how many students usually will get C? Can we say the majority? No, right? Not majority of the students will get C. So this is actually here where we have the C grade. We will have, let's say, 20%. If this is the proportion for all the distribution, maybe this can be the 20%. In proportion for the overall. How many students will get A? Because this is the A range, starting from 75 onward. Also few, all right? Or let's say also 20%. While the majority of the student will be in this bell shape. So here is about, let's say, 60%. Okay? If the distribution follows this bell shape, we call such distribution normal distribution. And that makes sense, because not all students will get low mark, not all students will get high mark. The majority of the marks will be located in the belly, here, in the belly shape. Okay? So this is called Gaussian distribution or normal distribution. If you wish to generate random values which follows this shape, the random distribution, you can call norm function. Okay? And this one simply you specify the mean. That means most of the values follow the mean. The mean here, actually the mean, if you, this is perfect, let's say perfect normal distribution. So assuming it's perfect, it's going to be 67.5. the perfect, let's say. It's middle value between 60 and 75. And then the scale is the standard deviation. The standard deviation for this distribution. Here means majority of the value should be around 0. When I put 0 here, that means majority of the value, the mean, is around 0. Different distribution. So if you like to present the marks for the student, then you can put here 67.5, and you can leave standard deviation by 1, and then the size maybe 100. We are looking for 100 students. Then the grades should be follow this normal distribution. But of course, 0 will be probably included as well. Okay, great. So now all of you knows what Gaussian distribution. Why we need to know about Gaussian distribution? We're not actually going to mention much, but some analysis requires, in order to have valid output results for the analysis, they assume that the data you have is normally distributed. And then if it's not normally distributed, there are some treatment where you can apply on the distribution to make some shift, to make it look like normally distribution. Okay, good. Now we carry on before some of you start to sleep or fall asleep. We go to advanced operation. So here we are just going to see how you can do masking or filtering. So here in this case, we are looking for all, let's say, numbers which are greater than value 30. So this is mask, or just this is, you can call it filter. If you like to sort out, then you can call function sort. If you like to find the maximum value, same like before, you can call max. If you like to call function argmin, then you can call argmin. But what is argmin? Anyone knows what argmin? Minimum value. But we have min. We can use min. This has the min part, yes, but it has arg. There's argmin, argmax. Argmin. Sorry. Find the minimum, right? But minimum of what? So it's gonna give me after all what? Okay, so it's gonna, oh, no, it's just gonna give me the index of the minimum value. So that means it's gonna search. If we check this array, where's the minimum value? This one, right? What index this value is located at? 2. So the output is gonna be 2. So if you wish to get the minimum value from the minimum index, very easy. Then you can type min val equal array with minimum index that you found, correct? Because this one just simply is going to tell you where is the location for the minimum value. But it's not the minimum value, it's the index of the minimum value. And same, there's argmax. If you wish to get the index where the maximum value is located, then you call argmax. Okay? Yeah, and here just print out. So this is the end of NumPy practical session. We're not done yet, huh? So we still have pandas, because this session is about NumPy and pandas. Now we're done with NumPy. Now we move on to Panda. In order to go to Panda, you go again, open notebook. And then you need to go to the GitHub, practical. And then we have another session, practical 2. Part 2 is about pandas. Now it says changes you made are not saved. By the way, inside Colab, if you add any code, it's not going to be safe anywhere. So what you need to do, if you wish to keep your changes, what do? You bring your phone and capture photos, right? Actually, there are several ways. You can click copy to drive. So this notebook is going to be saved into your G drive. Or you can go to file, and then if you have GitHub repository of your own, then you can save a copy in your GitHub. Or you can go to download and then download this notebook. So this notebook is going to be downloaded to your local machine. Then you have pen drive, you can copy the notebook to your pen drive. Then you can take it home. Then you can have dinner together. you and your notebook. Okay, good. Now I'm not interested to save any changes, so I'm gonna ignore the message given by Colab and just go to Pandas. Limit exceeded, authorize Colab to use, cancel. Okay, so Pandas. What is Pandas? Pandas is open source library available. And the interesting thing, it's built on the top of NumPy. It's built on the top of NumPy library. In order to install Panda, again, if you are using an account, if you are working on an Anaconda environment or Colab, you don't need to, because this is one of the famous library. It's going to be pre-installed to you anyway. But if you work on a machine that doesn't have Pandas, then you can type pip install Pandas. Then you can import by calling import Pandas as PD. Pandas data structure. So this is the section about data structure. Pandas offers two data structure. There's series and there's data frame. Series, you can think of it as one-dimensional array, just as one column. If you wish to define a single column, then you can use series. If you have multiple columns, that means two-dimensional array, then you go with data frame. So series is one-dimensional array, just one column. Okay. So in this case, I can define, let's say I have one array to store these values. So I can call pd.series, then I pass the values. Then this is my series. It seems like I got two column values. What is the first column value here? So this is my series here. Well, it seems I have two column values. So what is the first one? It's about what? The index. All right, so this is the index. And these are the values that I have inserted earlier. Okay? Again, it is just one dimension. You cannot have two columns, just one column. That one is index. Okay, I didn't define. Now, if you wish to create two-dimensional array with dummy data, then you can prepare your dummy data first inside. What is this data structure? Of curly brackets. Curly brackets represents what? Nothing, represent nothing. Actually, it represents something. Represent dictionary, right? Square brackets, list. Curly brackets, dictionary. Round brackets, tuples. Okay. So someone has to do some revision. Okay, now we move on. Now we define data frame. Why data frame? Because I have multiple columns. I have these keys are going to represent my columns. Then I pass them, and this is my data frame. Okay, so I have three columns: name, age, city, and this one, same like the series. This is the index. Anyone knows where Rabat? In which country? This is capital city for Rabat. Yeah, very good. Oh, someone has studied good geography. Yeah, so this is the capital of Morocco. Cairo, Egypt, where pyramids. So pyramids are in Egypt. Cairo is the capital. Damascus. So, wow, well done. Okay, good. So Damascus is the capital of Syria. Okay. In order to read CSV file, then like same of last session, we call read_CSV, and we provide the CSV file. But if you run this inside Colab environment, it's going to give you what? Error. Why? Because the file is not on the Colab server. Now we are running the code on Colab server. So what to do? We remove this code, right? No need. We need to make sure that to import this file into Colab environment. In order to do so, we can go here to Files. Okay, because I'm not connecting, so now it's going to connect to the server first. Connecting. And now I got here my files. Then I right-click and do upload. So I need to have data.csv on my local machine. Then I click upload and then upload the file into Colab. Where to get the file from? From GitHub. So if you go to the GitHub Practical 2, you see that there is data.csv. So you can download it to your machine, then upload it to Colab. Okay, good. Now we move on to data manipulation with Pandas. So here I got my data frame for this dummy data. And then in order to access the first two rows, what functions I need to call? Head. Head, and then I provide two. This will yield the first or the top two rows. How about if I need to get the last two records? What function I need to call? Tail. Yeah, good. So I need to call df.tail. This will give me the last two records. Now, if you like to access specific value, so you can use indices like as we've done in NumPy array, and you can use iloc. So iloc is for indices, where you can specify which value or element you wish to access. So in this case, I'm looking for the value located at row index 0 and column index 0. If I check my data frame, that means I'm looking for this name, this value. Okay? Now, if you wish to use the column name instead of the index, if you like to use the column name, then you need to use loc, not iloc. Iloc for indices. You can use loc, and in this case, my row indices are numbers, so I can still use number here, referring to the index, row index 1, and the column name is name, this one. So row index 1, column name, then I should get Muhammad. All right, so here this one, if you run on your device or just check the answer, so you should get, what is it? Here. So the value in the name column at index 1 is Muhammad. Now, if you wish to get more than single value, then we need to use slicing. Same way like as we done earlier in NumPy. Okay, so we need to use slicing. So in order to use slicing with indices also can. So we can use iloc. So this one means all rows with the first column, column index 1. So this one should retrieve age column here. If you wish to have subarray, then you can also specify. So this one means I like to get values from row index 1, row index. Come on, someone, please help, talk. Row index 1 and row index 2 and row index 3. Come on, remember, this is exclusive. So it's not going to be selected anyway. Though we don't have row index 3, but anyway, it's not going to be selected. Right? So that means only row index 1, row index 2. And then here, which columns? Column of index 0, column of index 1. There is no column index 2, right? This is exclusive. Always remember, The ending index is exclusive. What does it mean exclusive? Not included, is outside. Okay, same here. So as a result, 1 and 2, 1 and 2. Right? Sorry, 0 and 1. So 1 and 2, 0 and 1, that means these values. This one. Muhammad 30, Omar 35. Okay? Bagus or not bagus? So this one will give me this subset of my data frame. So please always keep note, the ending index is exclusive. Exclusive. Like when you go to buy an item, and then what they say, the tax is either inclusive or exclusive. Exclusive, that means you still need to pay more later. Once you go to the cashier, they're going to calculate the tax and then tell you how much you need to pay. That means the price tag didn't include the tax, right? How much amount you need to pay for the tax. If it's inclusive, that means just you go, this is what the total amount you need to pay at the cashier. So same idea, inclusive, exclusive. Okay, no need now to do shopping. Let's go back to Pandas. Okay, now what else we still have? So I lock, so you should be okay now. Now, if you wish to do filtering, same like as we did earlier in NumPy, we can also specify the filter condition. So here I'm telling NumPy data frame, I like to get all people whose age is greater than 30. How many people, their age greater than 30? Only one. Omar, whose age is 35. So this one will give me this one. The output. Now, if we wish to add a new column into my data frame, you don't need to go back to the dictionary and add. You can, actually you may, but there's an alternative way, because sometimes some columns are calculated. That means only after you load your data frame, you wish to do some new column based on calculated value, based on other columns. Then how to add a new column? You can just go and type the new column name. So here I'm saying I need to add a new column called salary, and these are the salaries for each and every person inside the data frame. So my new updated data frame looks like this. So now I have also salary among the columns. Okay? Okay. Now, if you wish to update the age of the people, let's say you want to increment people's age by 1. Remember, we've done similar task last week. Do you remember the function name we called last week? Do you remember? Again, shake your head. Maybe you can find it. The functions start with A, P, P, L, Y, apply. Right, so we used lambda function last week with apply function to increment the age. But there's easier way. Another way, just like this. You tell data frame, for the column age, I wish to increment the value by 1. Then you store back to the same column or to new column. If you wish to store the age, the updated age into new column, also can. By all means, huh? Nobody will hold you. How about if I need to drop column from my data frame? Then there's a function called drop. So for drop function, you need to specify the label, means the column name in our case, and then the axis. What does axis do here? The drop function can be used to drop rows and columns. Now, how drop function will differentiate whether you're requesting to drop rows or to drop columns? By the argument axis. So if you say axis equals 0, means you are dropping rows. If you are saying axis equals 1, means you are dropping columns. Or easier way, you can type axis equal columns, also can, instead of 1. And for instead of 0, you can type index. That means rows. Okay? Bagus. So this one, columns. Then we have in place. What does in place do? In place is an argument you can specify to tell data frame whether you wish to apply the changes, in our case dropping the column, the changes is to drop the column on the existing data frame, or to create a new data frame and remove the column from it. So if you wish to do the changes on the existing data frame, then just you type in place equal true. That means the original data frame is going to be affected and the column called city is going to be dropped out. Clear? If you say in place equals false, then the original data frame won't be affected. A new data frame is going to be created without the column city. And of course, in this case, you have to type like this. Maybe let's say out city df equal df.drop, because drop is going to create a new data frame. So I need to catch the data frame. I need to hold reference to it. This is only in case if in place is false. If in place is true, then no need. This one we don't do. Just df.drop. Okay? Now we move on. Now, how to handle missing values. Remember last week also we mentioned a little bit about missing values. Also, we're going to mention again a little bit, another little bit. Later, we're going to have a session talk about more about data quality. But data frame also enables you to deal or to work on missing values. So let's say I got this data set, I added new person, or I changed even the existing one. So this is my data frame, and if you notice, I have two missing values. I have two missing values. One of them is for Omar. We don't know his age, how old he is. We have no idea. And for Hannah, we don't know her city, right? So we have two missing values inside this data frame. Okay? So what we need to do in this case, missing values are no good inside data. It's the main thing you feed into your algorithm is data. So you need to find a solution for missing values. One of the solutions is to drop these rows, to remove them, because they got missing value in them. Okay, so in this case, I can call a function called drop NA. So this function is going to check row by row, scan record by record. If the record got missing value, it's going to be excluded, dropped out. Or another way, sometimes we don't drop rows for some missing value. Not all the time we remove the rows. Sometimes you have small data set. Remember in last lecture we said one of the main challenges of data mining is having sufficient data. So sometimes if you have low number of records inside your data set, so dropping your rows may not be a good solution because you are reducing, you're making your data set even smaller. You have an issue of small data set and yet you are reducing the size of your data set. So in this case, we wish to do some replacement. We fill those missing value with some value. Okay? Of course, not unknown. Unknown doesn't resolve the issue. This is just an example to show you, and already says here, fill missing value with a specific value, but not unknown. This is just to show you where there's a function called fill NA. Like drop NA, there's fill NA. Now, if I ask you what is the proper way, just intuitively, if you're not attending mathematics or whatever, or statistics, so what would you recommend to replace values for age? for people whose age are missing. Yes, sorry. Yeah, so what would you recommend? Just say anything. Sorry? Yes. Yeah, so one way we can get the mean. Mean means the average. So I can assume, one of the statistic way, I can assume that those people who got missing value, their age is just the mean value for all other ages, all other available ages inside the data set. So I go and calculate the mean for those 3 values, and then I replace this missing value. What other statistics we can apply? So we have mean. What else we have? Median. Have you met median function before? Median. What is median? What does median do? Exactly. So it's about finding the value in the middle. So for median, you need to sort out first the values like age, sort, then find what is the middle value in this column, then you choose it as replacement value. How about city? Can I use mean and median? Why can I use mean? If I mix all these cities, find the average. What is the average for all these cities? It's not logical, right? So I cannot apply mean. How about median? Can I apply median? Why? Yes, sorry. Have alphabet. Okay, can be, but actually, if we take it, doesn't make sense to sort out the values for the country by alphabet. No, right? But actually, just coming to think about it, if you use the alphabet, maybe can. But anyway, for text value, usually for categorical, if we don't have if they don't have nature of order, we cannot say Damascus should come first, or Cairo should come first, then second Rabat. We don't have definition for order. Okay, then in this case also median is not applicable. But if we're talking about level of education, then yes, we know that maybe high school, then followed by diploma, degree, postgraduate, and so on. So it depends on the nature of the variable. We're gonna talk also about this later, okay, when we go to data quality. So this one, what we can apply in this case, any other more reasonable solution? Mode. So what is mode about? Most frequent value. Very good. Well done. So actually, it's logical. If I got, let's say I'm talking about states of Malaysia. And if I check, I found majority of you come from Perak, for example. Then I can assume those people who have missing state name, they are also coming from Perak, because the majority of the people for this class coming from Perak. Logical, right? So this is why I told you in this class, the good thing about this class, you can think. You don't need to memorize. If you think, you're gonna be safe. You're gonna be always like floated on the surface of the water. If you stop thinking, you start to drown. A little bit, keep droning until you hate this class. So always, if you want to stay floating, think why we are using this, why we are using that. There's some logical reason behind them, which gonna help you to stay always focused, able to understand what's going on inside this course. Okay, enough about missing values. Let's go to data exploration and analysis. Also, Pandas offer you a lot of functions to do exploration. So here I got this data set. I prepared my data frame. Then there are many functions I can call. Like, for example, if I wish to calculate the mean of the age, then I can specify the column name. Then I call function mean. If I wish to find the median value for the salary, then I call median. If I need to find the minimum age or the maximum salary, I can also call min and max. There is another function called describe. So describe, what does it do? Generate descriptive statistics and give you summarization about your data set. So if you call describe, it's going to give you this result. So it's going to give you what is the mean, for example, for age, the standard deviation, the minimum value, the maximum value at the percentile, the values at each percentile. It's 25%, 50%, 75%. Same for salary. And notice that name and gender are not included. Because logical, can you calculate mean for name? Gender? Can't, right? So those are excluded by default. That means only numeric columns are included. There's another useful function. It's not mentioned here, but you may also wish to know, is print df.info. Info is helpful if you wish to get some information about the column names, the data type for each column, how many missing values you have in each column, so you can use info. Okay? Also, you can apply aggregation. If you are good in SQL, and when we talk about aggregation, then don't be sad. You can also do aggregation here. You can bring your skills from SQL to Python to data frame. For example, here we are asking to group by the records by age. Now, if I inspect my data frame, I have two people with the same age. Right or right? Right. So here, these two people, they're gonna be grouped up, and then I'm looking to get the mean for their salary. Why their salary? I didn't specify salary here. That means only for numeric columns. The only left numeric column here, in addition to age, is salary. All right? So this one is gonna give me the mean value. So if we check, this is 25, 25. What is the mean value for salary 50,000 and 55,000? What is the average of 50K plus or 55K, 50K and 55K? The average is $52,000. Yeah, 52K 500. So 52,500. So this is why here I got 52,500, because I use group by, then I call mean. So I got the mean for these two people whose salary is 50K, sorry, whose age is 25. Then I got the mean value for the salary. The rest, no changes, because their age are unique. I don't have other people of 30. So 30 as age is unique, 35 is unique, 40 is unique. Okay, good. Now we go, if you wish to use apply, there's also function apply. Let's say here I'm looking to create the squared value for the age. Then I'm calling apply, then lambda. We already used lambda last session, so this is another example of using lambda. So each value of age is going to be raised to the power of 2. Okay? And then the value, the result are stored into new column. I don't want to disturb the previous values, the original value, so I created a new column. Now, if I wish to filter, retrieving only specific rows based on condition, then I can use query also. There's another function called query. So here I'm looking for objects or records whose age is greater than 30. If I inspect my data set, I have two people whose age is greater than 30. So it should be Saad and Hannah. So here, where is it? Can you see Saad and Hannah? Here. Okay. One more function is called cross-tab. Cross-tab is nice if you like to get cross-tabulation, where you can see how your data or objects or records are distributed. So for example, here, let's check this example. I'm creating cross-tabulation for two columns, gender versus salary. then I will get this output here. So these are the unique salary I have. I have 50K, 55, and 60. And then for gender, I have only two values, male and female. Then from this cross tab, I can know that I have one female whose salary is 50K, while I have one male and one female whose salary are 55K, while two males who earn 60K, and 0 female. Okay, so this is an example about cross tab. Can be useful always because we like to get some info about our data. We like to gain some insights from our data, so this is why we apply all these functions. Finally, then I can have my voice relaxed a bit. We can also do plot because data frame also support visualization by using the library matplotlib. Last week we also introduced. So here in this case, I'm calling data frame. I wish to do visualization by calling the function plot. I specify the x-axis, which is the column name. The y-axis is the column salary. And the type of plot is bar. Remember, we talked last week, we have histogram, line plot, scatter plot. We have also bar plot. So this is bar. And the title for the visualization component is salary distribution. Then we get this output. Okay. My part is done. Now it's your part. So you can go to the Jupyter Notebook and then try to explore, do some changes, and see the result.